Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we are going to discuss question number 6. Use the graph function g of x to answer the following questions. Look at the graph. Is g of x continuous on the open interval -1, 2? This is -1 and this is 2. Now look at the graph from here to here. Is there any break or hole in the graph? No. So the function is continuous on the open interval from here to here. It is open interval, so this -1 and 2 are not included in this. And look at the part D1 of this question. Is g of x continuous on closed interval -1 and 2? Now look here. This here any hole? No. There is any hole? No. So the function is also continuous in this interval. Now for part B and C, I am going to prove it. G of x equals to minus x square plus 2x plus 2. Part B. Is g of x continuous from the right at x equals to -1? So limit x tends to from the right to -1, g of x equals to, put here -1 in the right side, so -1 square plus 2 into -1 plus 2, we get -1 square equals to 1, so it is -1, minus into minus, we get -2. In here plus 2, these two cancel with each other, we get -1, so the limit exists. And now g of -1 equals to -1 square plus 2 into -1 plus 2, which equals to -1 -2 plus 2, these two cancel, -1. So now look, the function value, this limit x tends to -1 from the right side of g of x equals to g of -1. Thus g of x is continuous. Similarly, g of x equals to minus x square plus 2x plus 2. Part C1 is g of x continuous from the left at x equals to 2. So for the left, we take the limit x tends to 2 from the left side, right here minus above over it. G of x equals to put the value here 2 minus 2 square plus 2 into 2 and plus 2. Here we get -4 plus 4 plus 2, these two cancel, we get 2, so the limit exists. And also g of 2 equals to minus 2 square plus 2 into 2 plus 2, so here we get -4 plus 4 plus 2, these two cancel, we get 2. Now look, limit x tends to 2 from the left, g of x equals to g of 2. So the function is continuous at x equals to 2. Average rate of change. The ratio of change in dependent variable to the change in independent variable is called average rate of change. That is del y by del x. This is called average rate of change. Suppose we have a function y equals to f of x. Here y is dependent variable and x is independent variable. Now the average rate of change for this function will be how? Let we are adding increment on both sides. Y plus del y equals to f of x plus del x. What is this del y? This is change in dependent variable, and this del x is change in independent variable. Now shift this y to the right side. Del y equals to f of x plus del x minus y. We know that y equals to f of x, so put here del y equals to f of x plus del x. The y value is f of x. Now divide both sides by del x. Del y by del x equals to f of x plus del x minus f of x divided by del x. This is the formula for finding the average rate of change. Now graphically, let us suppose this is y-axis, this is x-axis. We have a point here. Let p of xy. Here the value is x, and on y-axis its value is y. Now let us suppose change in x is del x. Here this is del x, and change in y, this is del y. So these two meet here. No, these two will meet. This is x plus del x, and this is x plus del y. So x plus del x and x plus del y both meet here. Look here, x plus del x is this complete, and this is x plus y plus del y. So both of these two meet here. Suppose this is point P and this is point Q. So now look, meet these two. And the f of x function graph will be like this. It will be a curve. This is increment del x, this is increment del y. Now what is this line? This line is secant line. Secant line, and the slope of this secant line is called average rate of change, del y by del x. This is the slope of which we find here. Here the coordinates of this P are x and y, and the coordinates of this Q are x plus del x, y plus del y. So the average rate of change in y per unit change in x is the slope of secant line PQ. The slope of this secant line PQ is the average rate of change in y or dependent variable per unit change in the independent variable, which is x, del x. Average change is del x. Now we will solve the exercise question by this formula. Exercise 2.1. Find the average rate of change of the following functions over the indicated interval. Y equals to x square plus 4 from x equals to 2 to x equals to 3. So solution, let f of x equals to x square plus 4. So x plus del x will be equal to x plus del x square plus 4. Put here x plus del x. So it will become, expand this square, x square plus del x square plus 2x del x and plus 4. This is f of x plus del x. And what is del x? Del x is change in x, which is 3 minus 2, which is 1. Now 3 minus 2 equals to 1. How we can solve it? We know the average rate of change formula, that is del y by del x equals to f of x plus del x minus f of x divided by del x. So put the values here. X square plus del x square plus 2x del x plus 4 minus the f of x value is x square plus 4. Look here, the f of x plus del x value is this one, minus f of x value is x square plus 4 divided by del x. Now we can write it as x square plus del x square plus 2x del x plus 4 minus x square minus 4 divided by del x. Cancel this 4 with this and x square with this. We get del x square plus 2x del x divided by del x. Take del x common. So here we get del x plus 2x divided by del x. This cancel with this. We get del x plus 2x. Now we know the value of del x is 1 plus 2 and the x original value is 2. It has increased from 2 to 3. So that's why we will put here 2. So when we will put here 2, we get 1 plus 2 into 2, 4, which is 5. The average rate of change or the slope of the secant line is what? 5, the answer.